So now that you've seen how to visualize print phrases, let's see how you might implement it. And this will give us a chance to talk about some other features that are pretty cool. So as we talked about, print phrases excuse me, uses a stream to convert a list of search results, a list of search results to a map that will associate the phrases in the input with the works where they were found. So that's kind of the big picture view of how the whole thing is visualized. And let's take a look now at what the code actually will reveal. So here's print phrases. You can see that print phrases is going to take a list of search results, which is obtained from the process stream method. We will then take the list of search results, convert that into a stream of lists of search results. We then go ahead and pipe that through flat map, and that will flatten the stream of lists of search results into a stream of non-empty search results. So that's what flat map does. And there's a couple interesting things about flat map. First, as I mentioned before, it ignores anything that's empty in the input, which is good. And flat map is interesting because unlike map, which always has to return the same number of output stream elements as there were input elements, or filter, which may return less than or equal to the number of input stream elements in its output stream, flat map can return less than, greater than, or equal to the number of elements. So if it turns out that there's nothing to flatten, it'll return an output stream that has the same number of elements as the input stream. If it turns out that once it flattens it, there's a lot more elements in the output stream than were in the input stream, it'll return more items. And if, for sake of argument, you had a bunch of empty lists of search results that were given to the flat map, then it could return less than the number because it would filter them out and get rid of them. So it's kind of a very interesting method because it can do all three variants, whereas map can only do one and filter can kind of do two. OK, so that's basically what flat map does. Yes, William? So you're asking, what is flat map doing? I'm sorry, I didn't quite understand the question. Yeah. Oh, got it. I'll explain that. So the question is, what happens after we do a flat map? So before I get to that, if I don't answer the question in the next 2 minutes, let me know, and I'll come back to it. So flat map can transform its input stream into a different output stream, and that's exactly what it's doing in this case, right? It's taking a stream of lists of search results, and it's flattening them to be a stream of search results. So that's what flat map is doing. And then that stream of lists of search, that stream of search results is then passed to collect. So of course, collect triggers flat map, among other things. And then it goes ahead and performs the following collector behavior. And the collector here is a grouping by collector. So keep in mind what it's doing. It's getting in a stream of search results, and it's going to do what the collector grouping by is going to instruct it to do. So I'll explain what that's going to do, and hopefully that'll answer your question. So remember, grouping by is this collector factory. It makes a collector that groups things, and you tell it how to group stuff. So you pass it 3 parameters. The key point is it's going to put it into a map, which is this thing up here. So let's take a look at what these parameters do. The first parameter is the classification function. And in this case, keep in mind, remember, we're getting a stream of search results, and we're going to make the key for the map be whatever's returned from the method reference search results : get title. And as you might expect, what the get title method reference does is it simply looks at the search result object that's coming through the stream and just calls the get title method on it, which will give it the name of the play, like The Tragedy of Julius Caesar or The Tragedy of Hamlet or whatnot. And it takes that, and then it uses that to classify things and make that the key in the map. And remember, when we talk about grouping by, you can think of it like the silverware organizer you might have in a drawer in your kitchen or your parents' kitchen. I didn't honestly have a silverware organizer for most of my college life. Probably never had one when I was in college, but my parents did, and I have one now. So this is basically where you put different types of silverware. So that's kind of what this is doing. It's saying, let's break it up into chunks. And so all the forks will go here, all the spoons will go there, and so on. So this is basically saying, make the title be the key in the map, which is, as you can see, is a map of string to list of search result mappings. And the next parameter, the second parameter, is the type of search structure to create. In this case, it's going to be a tree map, the type of map to create. So we pass in a method reference to a tree map. And a tree map is simply a map that uses an ordered binary tree to implement the map, as opposed to, say, a hash map, which would organize things in a different way without having them be sorted. So this will sort them by their title. So it'll be sorted by the title. And then the third and final parameter is an interesting one. This is a so-called downstream collector. And all that means, it sounds fancy at first, but a downstream collector is simply the collector that's defined after we take the elements of the stream and classify them into the keys in the map. So after we've taken the elements in the stream and we've said, oh, this is the tragedy of Hamlet, this is the tragedy of Macbeth, this is the tragedy of Julius Caesar, lots of tragedies in Shakespeare, obviously, and we made those the keys, then what we say is the values in the map are going to be the toList method. And what toList will do, as you can see here, is it'll take each of the search results that we've gotten as a result of our stream, and it's going to stick them at the end of the appropriate list corresponding to the title that they're associated with. So if you have something where the title is the tragedy of Hamlet, then each element that matches that will go into a list of search results that's stored in the map. So it's basically, as we saw when I showed you the original output, it's going to be the list of the name of the play, followed by all the quotes, all the phrases that occurred in that play. Those are the values of the map. William, did that answer your question? OK. So as you can see, grouping by is a very powerful mechanism because it allows us to select the type of map, it allows us to select the key, and it allows us to select the values, and then it's all arranged properly. And this is all done in like a one-liner, or two-liner in this case. Very, very, very concise. If you had to write this code by hand, you would have a lot of extra work on your hands to do all this stuff. But this is really straightforward, does all the work for you. So as a result, we end up with a map that maps the titles to the phrases that matched for that work of Shakespeare. Now, just to make this easy to read, I could have glommed this all together and not have created an intermediate map. I just wanted to avoid making it too confusing. So what we're going to do here is, now that we've got our map, we're going to use that map and we're going to iterate through the map. So for each element in the map, we're going to iterate through it. So this is the maps for each method. And for each key value pair in the map, the for each method will basically take this interesting lambda expression, and this is the type deducted version, so it leaves out the types. I could have expanded this to say what the types were, but didn't need to. So we're going to have key and value pairs. So for each key value pair in the map, where the key is the title and the value is the list of phrases it matched, we're going to go ahead and print the key, followed by all the values. So the key, of course, is the name of the play, and then the value is this list of search results. So for each search result in the value list, we're going to print the search result. So again, I think you'll agree that this is really concise, very straightforward, very simple. I could have made it even more concise by not creating the intermediate map, but that was sort of not quite getting the point across that it's creating that map, and then we're going to go ahead and iterate through it. OK, so that's basically how we implement this method, and I think it's nice because it illustrates a bunch of things. It illustrates flat map. It illustrates removing empty lists automatically, flattening the list of search results to a stream of search results, using grouping by to classify those things, and then using the for each method of the map to print them all out. And it's all really straightforward, very concise, not a whole lot of programming, just assembling the various parts of Java streams.